So hello, how are you? This is uh, overview lecture for exam P1. So here we're talking about a one variable continuous distribution. So a continuous distribution comes from discrete distribution, right? So a typical example is like a binomial distribution or close to a normal distribution, right? So for a continuous distribution, we use the curve to describe the distribution. So there's a curve, you use a function. So there's a curve, there's a function, we call it density function. So density function is just a probability, or just a probability function in discrete situation. So just a probability, right? So for probability, so we have two requirements. First one, probability cannot be negative, right? The second one is all probabilities together should be 1. So here integration for this function, for the density function fx is 1. So if we want to find the probability between a and b, so this just becomes integration from a to b for this density function, right? And the expectation becomes this integration. X times fx, before we say x probability, right? Then add them up. So we just changing this to integration to continuous form is just x fx dx integration, right? So the formula for variance is the same. Okay, x squared minus square x. And so this, we call this function is just a cumulative function, cumulative distributive function. This is suppose we have this density function. So the probability for this part. So we say this probability is a cumulative part. So let this x can change x. So this probability is fx. So we call this as just the cumulative distribution function. So if this function is continuous, then we have this, right? We know the derivative of upper fx equal density function. So for continuous situation, we just involve source integration, one variable integration. So we have 3 kinds of integration. First one is with a power function, x alpha dx equal alpha plus 1 x alpha plus 1, right? And exponential x dx equals us. And there is a combination with a power function xk is x. So for such integration, we need integration by parts. We need this formula. Okay. So for example, like this one, x dx equal this. We put x dx. So x minus this. So for integration, so such a those problem is most difficult one. Like we need integration by parts. Okay, so you could also can say like this one is also quite complicated. We need integration by parts. So for this one, like x squared x. So those are just we can say this is just too complicated. such problems usually will not appear in the exam. Okay, so for integration, we just have this basic have this two. So for integration for others, the basic skill is use substitution. Like substitution is just make simple or make the problem simple, just like this one. We like for this one, let's say we only know is x, right? Or so we just use this substitution. We just say let negative 2x equal t. So this just become et, right? So et, the integration for et I know. So if we changing this negative 2x as t, then we need to change everything. So for example, for the upper bound, lower bound, so x equal 2, then t equal negative 4, right? So x equals 3, t equal negative 6. Okay. Then what is dx? So we also need to change dx to dt. Dx, so negative 2 dx equal dt. So dx equal negative half dt, right? So negative half dt. So we just changing everything to t, right? And then we take negative out the coefficient outside, and so here integration usually from low bound to upper bound or small number to large number. So this we just take this equal negative half, and then so negative 4 to negative 6. We just changing this to negative 6 to negative 4. So this become this give me another negative. So here it become positive, right? So just e t dt. Okay. So like for this one, I only know 1 plus x. I only know like t some power. So I just let this equal t. So this integration become t negative 2, right? Okay, so then just changing this dx to dt. We find that dx is just equal dt, and then this t become so when x equal 2, t becomes 3, and when x equal 3, t become 4. So just this integration, right? So we can apply the formula. So these are the basic mathematical skills. Okay. Okay. So we see many problems for those continuous one variable continuous distribution. Many of those kind of problems are just math problems, just integration problems. So for example, it says we have this density function. We want to find some probability. So here we giving that. So this is just giving that is a conditional probability. We just check those conditions. This loss. So this is x meaning loss, right? So conditions x. We just want to find this condition x larger than 8. Under this condition, we want to find the probability x larger than 6. So this probability equal total x larger than a. Then use the formula a and b like this just become x larger than 6. So for those probabilities just become integration, right? So let's say we check x larger than a. equal, so this equal what? Larger than a, so a infinity fx dx. Alright? Okay, so here we don't need to go to infinity because x just between 0 to 20. So we just say this equal a to 20. Then this fx, so this coefficient 20 minus x. So this is just equal 0, 0, 0, 5. So here 20 a 20 minus x dx. So here we have some small scale, like because this is probably we have this coefficient, this probably we also have a coefficient, so we can forget this coefficient 0.005, and we just focus on this integration. So for this integration, we just use a substitution. We let 20 minus x equal t. Okay, so then so when x equal 20, 0. When x equal a, 20 minus a, right? So this is just the equal t. So here dt, but dt, but we have negative, right? So we can have this like, so this equal just the half t square. Half the t squared 20 minus a square. So go back to this problem, so we can say we also can cancel half. So this is 20 minus 6, minus 8, 16 square over 20 minus 8 square. Okay, so for this problem 2.2, we want to find expected value, so expectation. So just use the formula x equal x fx dx. So x from -2 to +4. So since this fx we have like absolute value, so we just we can regard fx, we have this fx is piecewise defined. So we just check this from -2 to 0, or from 0 to 4. Okay, so we just check it into 2 parts. So from at the first we plug in, so there's 10 again. Okay, so for this we just split as into 2 parts, right? From -2 to 0 says absolute value for x negative x. Okay, so by now this integration is really very easy, right? So for this one is like a negative -2 to 0 x squared, and this is 0 to 4x squared. Yeah. Okay, and maybe here we also can say like this x squared from, let's say this integration x squared from -2 to 0. This one equal from 0 to +2, right? So this is from 0 to 4, so we can change this to like from 0 to 2 cancelled, from 2 to 4x squared dx. Okay, so that's equal 1 over 3 x3, right? So x3 is 4 3 minus 2 3. So we can say like such a problem is just like a math problem. Okay. So we say all those kind of problems are the same. Like here we want to calculate the probability that the lifetime is less than 6. So we want to find this probability. This x less than 6. So at first we need to find the density function. So let's say density function is proportional to this. So we can say density function equals this. So at first we need to determine this k. Right? So how can we determine this k? We say that all integration of all probability equal 1. So from we just let this equal 1. Okay. So from here we can find this k. So find this k, we just use the integration. We just find this integration, right? So again, like we use substitution. We let this 10 plus x. We regard it as equal t. So this become t negative 2. And then upper bound, lower bound. So when x equals 0, this t equal 10. When x equal 40, this t equal 50, right? So once we find this k, then find this probability, just integration between 0 to 6, right? So this is k. We find this k. We take this out. So this is just this integration. So for this integration, quite the same. Okay. Okay. So now let's say there's a problem. So what we wanted to do, you find the conditional probability set. So what the condition is that v exceed this, giving that v exceed this. Okay. So this conditional probability we want to find. This probability, this v larger than this, giving that v larger than this. So such a problem is just equal p v larger than 1 10,000, and here v larger than 4,000, right? So such a problem such a problem is the same as our first example. So we just need to check, let's say we just need to check this. How about v larger than a, right? So we don't need to find the integration twice. We just use the formula, like check this. Okay, so what's the density function? So density function is this. And so what is v? V equal this density, that's the y. Then we okay. So what are the density functions? We have the density function for y. Then we just change this v to y. Okay. So this just equal. So we just say this first one just equal in terms of y. So just y larger than, let's say 0.4, right? Yeah, 0.4. So v equals that. So like 0.4 and y larger than 0.1. Okay, so we just check this. Yeah, y larger than a. So y larger than a is from a to 1. k1 minus y 4 dy. So if we find there's a probability, we need to find there's a k. But since k will be cancelled, so we don't need to care the k. So we forget it as a k. So we say this equal. Forget it as a k. Or we can put a k other side as a k cancelled. So this one is substitution. We say this equal so t4, right? So dt and negative. So dt then when y equal 1, this becomes 0. So this is 1 minus a. So we can really quickly find this probability, this equal. So this is equal, and this integration of 1 over 5. So this 1 over 5 also cancelled. So this is just equal 1 minus a fifth power. So answer just like that, right? Okay. So such a problem almost quite the same, like giving that. Okay, so let's say giving that the condition is we want to find what is the probability that this is less than 2. Okay, so such a probability we want to find is this things x less than 2 under the condition is this x larger than 1.5, right? So this probability, conditional probability equal x larger than 1.5, and here's x between 1.5 and 2, right? So for those probabilities, we just need to find this integration. Okay. So for example, like what is this x larger than 1.5? It's easy, right? So this equal x from 1.5 to infinity, but yeah, okay. So here x larger than the upper bound is infinity. So here 3x negative 4dx. So this integration negative 4, let's say negative 4 is negative 4 plus 1, negative 4 plus 1, x negative 3. So, okay, so this is just equal x negative 3. Okay, and from this to that, so this is just equal 1.5 negative 3. Okay, so this is equal like 1.5 negative 3. So this one we can say this is so 2 is like so we can say this equal 1.5 negative 3 minus 2 negative 3. Okay. Okay, so for this problem, we want to find expected value, expected monthly query. So let's say, so at first we say the density function proportional to that. So at first we need to find the coefficient. Okay, so equal k 1 plus x -4, right? And what is x range? X range is between 0 to 8. Okay. So at the first we need to find this k. And what we want to find is just find x. So x is equal x fx dx. So x from 0 to 8. So here at the first we just need to find this k, right? This k, so integration equal 1. So we just check this. Let's say from 0 to 8, this 1 plus x -4 dx equal what? So we use substitution. We just let this equal t -4 t. So 1 plus x equal t. So this t become from 1 to 9, right? And this t -4 equal -4 plus 1 -3 t -3. So from 9 to 1. So this equal so this equal so t. So we just take 1/3. So we just check this negative. So we just pick t equal 1. So 1 minus. So t equal 9. So this equal 9 3 1. Okay. So this equal 1/3 9 3. So 9 3 minus 1. Also here just need some calculation, right? So this is this integration. So this thing is k. So this number multiply k equal 1. So we can find this k. Yeah. Okay. Negative. Okay. So then we can find this integration. Okay. So for this integration, let's say, suppose we have this k. Actually, k equal just equal this, right? 3 times 9 3, and 9 3 minus 1. So I think this number is quite big. So this x times fx. So x times fx integration becomes this. We forget the k. Okay. Or put the k outside. X, what is fx? So 1 plus x -4 dx. So here we have a little bit math skill. So this is the 1 plus x -4. We put 1 minus x is 1 minus, so 1 plus x is 4. So we change this as 1 plus x. We just change x to 1 plus x minus 1. So if this 1 plus x, this become -3. Oh, no, 8 dx. So then minus 1 plus x -4 dx. Right. So this is just the integration problem. Okay. So for this exam P1, so this exam we say like for actually is involve lots of risk management, like insurance payment, right? So the different policy will have different payment. Okay, so we have those words like deductible or copay or limit. those things. So we should understand those notation. So deductible meanings like deductible. This means like if the loss damage is between 0 to C, they will pay 0. The company will not pay. Okay, or like you should be responsibility for yourself for this money. Okay, so then larger than X, this part, they will not pay all, just pay X minus C. Okay, so the payment Y is thus. Okay, so this is C, we call it deductible. Like if you have $500 deductible, so this means the less than $500 you need to pay by yourself. If more than $500, you still need to pay $500. Right? You need to pay $500. Then remaining one, the insurance company will pay. Okay, so copay, you have a 20% copay, means you pay 20%. The company will pay 80%. Right? So copay, so percentage D, so you pay D%, they will pay remaining. So payment is 1 minus D times X. Right? So limit means like the at most will pay this. So if cost, if damage is, let's say, at the most they will pay this. So up this, they will only pay this. Okay, so this payment of Y. So here they will pay all, they will pay X, and here just they pay L. At most pay this. Like suppose they have a limit for $10,000. So above $10,000, they will just pay for $10,000. Okay. So sometimes we can put those together with deductible and with copay. So the payment becomes thus. Like so, they only pay this part. Okay, only pay this part, and they will pay remaining. So you pay deductible. So this is X minus C is after you pay deductible, they also will not pay all. They pay like 80%, right? Okay, so like if you have deductible C and the limit, so the payment like this, like okay, the loss is okay, so limit is L. Okay, so copay, not copay, deductible means you always need to pay C. So if less than C, the company will pay 0. If between let's say, so here so here the confused like limit. So with the deductible, this limit you need to be careful that this limit is the company will at most pay this. Okay, so here if you already lost here, like suppose like you your copay, your deductible is $1,000, limit is $10,000, so they will at most pay $10,000. So loss, if loss is here, L plus C. So then they will pay this X minus C. Just to pay this after your deductible, they will pay, and then so here just they will pay L. At most they will pay this limit. So you should pay C, right? You should pay all others. Like you should pay remaining. They will pay at most pay limit. So let's say suppose L equal 10,000. The company will pay at most pay this. So C C equal 1,000. So you use this example to understand this payment. So if the loss is, suppose the loss is 10,000, so you should, at first you should pay 1,000, right? So the company will pay 9,000. Okay. Okay. So if loss is 20,000, then company you pay this deductible 1,000. The company will pay 10,000. Then remaining one you should pay, right? Okay. Okay. So we have many of those kind of problems to find the expectation for the payment. Expectation of Y, or sometimes variance of Y. So such a problem we can regard like we know X. We know this X. But we focus on Y. So this Y is somehow related to this X. Okay. Like X is loss, Y is payment. So we sometimes will focus on this new variable Y, right? So such a problem we can regard Y as this variable's adjustment. So this is not exactly like transformation, but close, just a change, variable change, right? So let's check some those example. So at first, let's check so limit, or we also could just check minimum, maximum. So their minimum or maximum they will pay at most 3. So this 3 is just a limit. Okay. So now let's check this discrete situation. Like we have this x variable x. We can define some new variable like y and z. Okay. So what is the distribution for y? So y is minimum of x and 4. So we just take a smaller one. So if x equal 1, this y equal 1, right? So such a probability is 0.1. So if x equal 2, this y take 2, right? If x 3, take 3. If x equal 4, take 4. If x equal 5, also take 4, right? So here we just put this. There's x equal 4, x equal 5. There's two cases. Y just the same, y equal 4. So this probability is 0.4. So this is just like a distribution for this minimum of this y. So for maximum, so this is maximum. So if let's say so maximum is like if x 5, maximum 5. Maximum we just check this side. If x equal 4, c equal 4. So all those 3 cases, we just take 3, right? So this is probability 0.6. So this is the distribution for z. So we can say that such a problem is just we know x distribution, find this maximum or minimum. So for discrete situations, easy. So for continuous distribution, you should be careful. Let's say for continuous distribution, so we call such a so continuous distribution. Some part is discrete, some part is continuous. So we will have those mixed distribution. Okay. So let's check this example. Suppose x as a density function thus. Okay, so we know x, and this x ranges larger than 0, so x can be just larger than 0. So this is y, the definition y is between 0 to 1. If x between 0 to 1, y is 0. If between 1 to 5, this y just equal x. And larger than 5, we just take a 5. So just like we have limit for the payment, right? Larger than 5, I just take 5. Okay, so we find EY. So this EY is the when x between 0 to 1, so y equals 0. So so here we just check the distribution. So distribution, so some part, so here y always equals 0, right? So the probability is when x between 0 to 1. So in here, this y can change, y equal x. So density function probability is fx. So when x larger than 5, when x larger than 5, so y is 5. So y equal 5. So the probability is x larger than 5, right? So we change this, so we can find those probabilities. So we have such a distribution. We have this part is discrete. This part is discrete. Here continue, right? So the question is find y. So expected y. So this equals 0 times this plus. So here x times this. So this is a continuous situation. So x times fx. So from 1 to 5. So plus 5 times this. There's a probability. So here we just, so by now we just check it. So this forget. So this equal like 1 to 5. So x. So what is fx? So fx is 2. Fx is 2 negative 2x dx. So plus 5. So what is this part? So this part is, we say 5 infinity, so like 2 negative 2x dx. So we can use integration to do this. So by the way, so for this distribution, this density function, so we call this distribution is exponential distribution. So in general, for exponential distribution, so quite commonly used distribution, right? Okay, so in general, density function is thus. So for this exponential distribution, you had better to remember something. Remember some typical result from those exponential distribution. So we say this integration like from here, this part integration is just equal e negative lambda a. Okay, so this integration just equal e negative the lambda is 2 times 5. Okay, but the basic thing is you need so here this we can save some time, and for this one, so maybe we have to use for this part we have to use integration by parts. So here it's so for those integration you need to do some practice. You try to do this quickly, but the first thing is just make things simple substitution. So we let negative 2x equal t. So this become t negative t is t, right? We let the negative 2x equal t. Okay, then dx become negative half dt. Okay, and the upper bound lower bound become like x equal 1, t equal negative 2, and x equal 5, t equal negative 10. Okay, then simplify. Negative negative become positive. So from negative, no, this become negative. No, let's say this is t negative, then this is negative. Yeah, negative, and x equal 1, x equal negative 2, x equal 5, negative 10. Should it be negative 10 too? Okay. Let's say this is negative. Oh, I think I made, but anyway, like here should be negative 10 to negative 2, then half t e t t. So this one, so we have no good way, just use just the integration by parts. Okay. Okay. So we say for integration, from in mathematical point of view, such a problem is most of the tough one. Okay. So I hope you can finish this as practice. Okay. So for this one, if density function is this, we say such a problem easy. Okay. Okay. So now let's say suppose this x the loss, this x follow this density function. Okay. So we want to find giving a landing loss x, the probability that the insurance company is less than the probability of insurance payment. The probability that the payment is less than 0.5 is equal to this. So here, what is that? So giving a landing loss y, so means like a loss happened. So the probability payment. So let's say for payment is y. So we want to find the probability that y is less than 0.5. Such a probability is equal. So giving that loss happen. So x like larger than 0, okay, but x always larger than 0, okay. So this probability is 64. So we want to find this deductible. So let's say, so this loss x from 0, this loss from 0 to 1. Okay, suppose this okay, we set this deductible here. Okay, so if the loss is between here to here, between here to here, the company payment is 0, right? So payment is less than 0.5. Yeah. So payment, so this condition actually is, so if loss is here, then payment is y, this x minus c. So this probability actually equals this. The first equal like x between 0 to c. Right? So this part payment always less than 0.5. Okay, so plus, so x is between c to 1. So your payment, so payment is actually the x minus c, right? Payment x minus c. So this payment is less than 0.5. Oh, I'm sorry. Yeah. So when x equals c, the payment c to 1. So payment is, if this is the case, the payment is 0. Yeah, but let's say, so less than, so payment is x minus c, y less than 0. So this means x less than c plus 0.5. So this means this is x between less than 0.5 plus c, and also the larger than c. So when x from c to c plus 0.5, in this case payment less than 5, less than 0.5. So then the density function is fx dx. Okay. Okay, so what is fx? Fx is 2x. So 2x integration, we know 2x, and let's say 2x dx equal x squared, right? Integrate out. So this equal x squared or equal c squared. Plus, so this equal c plus 0.5 squared. So minus c squared, right? Okay, so this equal c plus 0.5 squared. So this equal 0.64. So we can find this c. Okay, so we let's stop here. We will continue.